The goal of each protection system is safe and selective tripping. Relays are connected to the CT's secondary side and can only make correct trip or no trip decisions if their input current is correct. Ensuring this is the task of protection CTs, which must be able to transform currents flowing in generators, transformers, or bus bars, ranging from a few percent of rated current up to many times its value for short-circuit faults. The classical way to specify such a CT is to define the expected maximum current which it will have to drive through its associated burden with a maximum permissible error. The IEC standard specifies a permissible error at a defined multiple of rated current for a nominal burden. For instance, 5P20 means that at 20 times the rated current, the CT must not produce an error of more than 5%. For C, K, T, and X classes, according to IEEE C57.13, a similar approach is used by calculating the terminal voltage from the CT's excitation curve and considering its winding resistance and external burden. For example, the protection class C400 means that for a burden of 4 ohms and at 20 times the rated current, the CT must not produce an error of more than 10%. This requires high driving voltages, resulting in the need for large iron cores. Thus, besides the ratio, the essential characteristics of a typical protection CT are its knee point voltage and magnetic characteristic, its winding resistance, and the relation of its nominal burden to its actual burden as it directly influences a CT's performance. The higher the burden, the less current the CT can supply to the protection relay without saturating. Magnetic characteristic and burden determine the CT's accuracy limiting factor, or ALF, according to IEC 644-1 and -6. Manufacturers verify these parameters during design, manufacturing, and acceptance testing. After installation on site, commissioning tests verify that the CT has not been damaged during shipping and that the connections are correct. The protection system must be connected to the correct core and, for tapped CTs, the correct tap with correct polarity. The burden is measured to verify that it is below the nominal burden. These measurements are usually repeated when recommissioning the plant, for instance after refurbishment of the control and protection system. In order to ensure reliable protection and correct metering, CTs must be tested at several stages during their life cycle.